Can you hear me? I hope you can. So, the ladies and gentlemen who are still outside are kindly asked to come back as we're going to move on. Before the lunch break, we had the presentation of the Technical University Darmstadt representatives. We learned about the different aircraft components and everything which can be done to reduce aircraft noise. And lots of questions popped up, and we're going to have further discussions on it. And we also learned what can be done when it comes to the fan, when it comes to the entire body, the flaps, the slats, and now we will have further details. We would like to get started with the aircraft manufacturers. They are going to give us a status update on research and implementation planning of measures for further noise reduction on aircraft. And Stefan Moal, acoustic expert and technical advisor at Airbus, is the first speaker. Hello, Mr. Moal. Great to have you here. And you've already heard a lot from the TU Darmstadt colleagues. You can probably elaborate on that. The Airbus A320neo was mentioned, and I learned that it's not standing for new. And you're also going to explain the increased bypass ratio. You're going to talk about the nacelle lining. You're going to talk about the wings, the development of noise pollution and the fleet renewal. And then you're going to explain the ICAO balanced approach to us, which will be something which will be mentioned probably on several occasions during this conference. And then you're going to talk about the Airbus sustainability strategy and give us an outlook on future aircraft architecture and research projects. We're looking forward to your presentation.
So I had no translation in this one, so I hope you said a good thing on me. Yes, thank you for the question and answer, if any. Okay. Thank you, everybody. Quite happy to be here and representing Airbus as a technical expert in acoustics. The presentation will be organized in that way. I will first look briefly at the long-term history on noise reduction, some success story like the A320, the A350. Yes?
Ich muss noch mal ganz kurz unterbrechen. Sie hatten gesagt, Sie haben keine Kopfhörer und vielleicht geht es.
You said that you don't have any headsets, and I don't see that many wearing headsets. If you would like to listen to the translation of this presentation, you can get a headset in the back and you will get the German translation. And of course you can also use your headset if you like.
But everybody gets it? Sorry, when I choose Spanish as a second language at school, I didn't know I would be there today. It was, as said just before to Rob, it was very useful because we are doing our certification flight test in Spain for Airbus, close to Sevilla. So it's very helpful for me to know Spanish, but still. Maybe I should start to learn German. Okay, let's start. So I will start about long-term vision about noise reduction and focusing on two success stories for the noise standpoint on the A320 and the A350. I will make a stop on the situation around airports, how noise has evolved in the latest years, which will bring me to the balanced approach and how Airbus is actively involved and more involved in local initiatives around the airports, which finally I will have a look further to our corporate sustainability strategy and the subsequent noise technology roadmaps that we have in Airbus. So let's go. So probably this graph, you may have seen it already. It's the full history of noise certification data from the early ages of 1960 up to the latest years. So noise reduction have been huge since the very first ages of aviation. We are talking approximately about 75% noise reduction when you compare the very first aircraft to the latest ones. Don't know if I have a, no, okay. What you can learn also on these graphs is that you have various chapters of certification. We have, I think, a topic on this one tomorrow. And we can see that all current Airbus aircraft, all the one in production today, have quite a margin toward the chapter 14, which is the current regulation for noise. So we do believe our products are quite good at the moment in terms of noise performance. The second learning of this curve is that noise reduction has not been steady over time. We had an acceleration period at around the year 70s when we moved from turbojet to turbofan. We have seen some explanation this morning with Steve Darmstadt. And the curve, the slope of the progression on noise reduction was around 0.3 dB per year per operation. In the 90s, the noise reduction were not so efficient. We approximately think that it's more around 0.1 dB per year of reduction that we succeeded to make. But it's the time when in Airbus we have launched a lot of research and technology on noise, understanding noise, being capable of predicting it and finding noise technology and to reduce it. And together with the high bypass ratio engine that come up at the beginning of the century, this noise reduction technology for the airframe, for the integration on the aircraft of the engine, for the liners technology, have been successful to recover with the initial slope of 0.3 dB per year. What's next? Let's see there. So two success story, A320neo, currently 12 dB below the regulations, so quite a good result. It is mainly linked to the engine, and by the engine I say the good work made by Pratt & Whitney and CFM on the engine design for noise, but also how we have integrated into the aircraft to avoid that we have interaction that would create additional noise, and the work on the liners technology. We have been hosting on this one the zero splice technology that you have seen this morning, developed mostly for the A380. So this is for the engine part, and it's a huge part of the benefit we made. But also, we have some additional points that were not in themselves a big reduction, but still participating to the good results, like the sharklets. So sharklets, it's not a noise technology. We don't have a specific noise source in there, but by improving the performance of the aircraft at low speed, the climb capacity has increased, and we save something around 1 dB just by the aircraft performance. That's something important to retain. Noise performance of the aircraft is not only about noise devices, but also by the overall aircraft performance. And it was also a question of small details, like I think you have heard about this one, the airflow deflectors that we had to put in front of the 4 small cavities we had below the wing of the A320, and they are whistling quite significantly. Not so much for certification noise, more for the operation around the airport at higher speed, and they are now baseline on each of our NEO aircraft. Looking at the A350, we went a little farther, because here we had a new airframe, a new wing, and we made progress on the engine. Again, 20XWB is a good engine in terms of noise design, with the swept top GV, good optimization for noise, good liners again, zero splice. But on top, we worked a lot on the airframe, especially all what you have seen this morning on the slats and the flaps. We have advanced droop hinge flaps, closing the gap between the flaps and the wing. We have a filled flap side edge also. So you see, we have put plenty of technology on the airframe so that the airframe of the A350 is also very good for noise result. Airflow deflectors are there for sure. We solve plenty of landing gear parasitic noise, like cavities you have seen this morning. And finally, it's also about operation, and the avionics of the A350 is equipped with all capabilities to fly enhanced procedure for takeoff and landing of the aircraft. Overall, so the 900 version of the A350 is 14 dB below the current chapter, and something like 16 dB versus the previous generation of the A340. So how these good results traduce in the real life around the airport? In the environmental report of EASA in 2016, it was said that among various drivers, fleet renewal, so the introduction of the new aircraft, has led to 12% reduction in the average noise energy. And maybe even more interesting, noise exposure has been stabilized over the past years, the past 10 years. So this is interesting. It shows that all these results that we have been doing already had an impact around the airports. But when we look, and this is an Airbus study dated from 2021, when we look at the number of new aircraft we have currently in the fleet, it's only 1/4 of the current fleet which has been renewed. So it means that only around 2040, we will have a full replacement by this new generation of aircraft. So all the benefits are still to come by fleet renewal in the airlines. Looking a bit further away, again, quoting EASA, fleet renewal could lead to reduction in total noise exposure at European airports over the next 20 years, but indicators may start to increase again in the longer term if manufacturers do not develop new quieter type of engines. So let's look at it in figures. The prediction for traffic growth, it's a bit difficult at the moment. Everybody's struggling to know how fast and how much will increase the traffic again after the COVID break. EASA has 3 different scenarios. And if they introduce the noise, they look at the noise effect of these various scenarios. First thing, you know, the study before was in 2016, and we have seen that the noise situation has started to decrease and to have more noise exposure around the airport just before the COVID, which was a warning signal. And for the future, they see that, yes, indeed, depending on the spread of the curves are linked to the technology, or the level of technology we introduce on the aircraft. So yes, we could be in a favorable position, but we need this technology. Just a short remark on that. All this study is looking only at, is not taking into account noise abatement procedures for landing and takeoff. And so any benefits on new procedure for flying our aircraft will be more beneficial than what you see on these curves. So we are going towards the local situation around the airports, and I have one slide on the balanced approach. I think that you probably have heard it before. It's an organization installed by ICAO and a recommendation on how to deal with the topic of reducing aircraft noise around the airports with different pillars. Noise reduction as a source, operational procedures, land use, and finally, operating restriction with the limitation that this one shall be used only at the last resort when you have not been successful in using the other pillars. So traditionally Airbus is a lot involved in the noise reduction as a source, for sure. We are also participating through operational procedures by enabling procedure on our aircraft and making the avionics capable of flying them. But what we are doing today is that we wanted to get more involved in what's happening around the communities. We understood that some procedures are not used, not because the aircraft is not capable, not because people don't want to, but just because we have not customized the procedure to the real use case that the airline and the airport have. So we are really moving towards the airport to promote and to customize low noise trajectories. Using all the best tools that we have in Airbus, we know very well our aircraft, we know how to best use it to reduce noise, to avoid the crowded area and so on, and we are proposing to airlines and airports some customized trajectories to improve the noise. We are also, and this is new since 1 year and a half, proposing our noise expertise inside airport communities activities. We are doing noise awareness sessions, like the photo you see on the right, that was with Aéroport de Paris people. Coming to the people, explaining to them, just as the question you had on the EPNDB and the DBA this morning to tell them the same question, they have it, the citizens, the airport representatives, the service providers for navigation, everybody has the same question. Noise is complex, so we go toward the people and we want to explain what are all these indicators we are playing with and what we can do for noise. On top of that, finally, something also we started a long time ago, but we really start to have some real benefits. It's about psychoacoustics. Psychoacoustic is the acoustic science around the understanding of the annoyance of noise. The problem of annoyance is not only linked to the level of noise you hear, it's also about some characteristics in the sound that are disliked or that are more annoying to your life. And we have been investing a lot in Airbus and doing 3 times a year some jury testing in a room like this. This is Airbus room for reproducing in 3 dimensions the noise of the aircraft and testing all our aircraft, testing all our technology to see what are the characteristics that are much or less annoying to people. Understanding that is really targeting what is annoying people and not only reducing noise as per certification objectives. To finish with, I will look a little bit forward again to the Airbus corporate strategy on sustainability and what is our technology roadmap for noise. Our sustainability strategy is a lot oriented toward the climate change and the impact aviation may have on it. So typically on 3 dates, Airbus is proposing 100% SAF capability on all the aircraft in 2030, offering an hydrogen-powered aircraft in 2035, supporting the net zero carbon emission targets by 2050. This is decarbonization. This is the impact on the climate of aviation that we are tackling, and it's a very important stake for Airbus. The question you may ask is the impact on noise management. So this question has been raised at the top level of Airbus, and we have discussed a lot, and we came to the following conclusion. All the technology we are looking at for decarbonization are not game changer for noise, neither in the plus or the minus direction. When you are thinking about hydrogen, electrification, new fuels, ultra-efficient aircraft, it will not automatically reduce noise, it will not automatically increase the noise. Just an example on that, when you are thinking about an hybrid or electric car in the city, yes, it's making less noise because you're running at low speed in the city. You have the benefit of not having the noise sources, the main noise sources, which is the engine. On an aircraft, the engine itself is not the main source. The main source is the fan, is the propeller, which is blowing the air, and this will still exist whatever you put behind. So electrification typically is not an automatic noise reduction technology, even if it introduces some benefits on decarbonization. On the other way around, you may think that propeller aircraft and open fan aircraft may be more noisy, can be, but we really want in Airbus to work on that very actively to propose noise reduction solution to make that acceptable in the same way as the aircraft as of today. Another element of strategy that we have been highlighting is that we are going toward a more integrated propulsive system. If you're looking at high bypass ratio, very close to the engine, if you're looking at propeller aircraft and the interaction with the wing, which is going both ways, by the way, or even buried engine inside a blended wing aircraft, for all this configuration, we have a strong interaction between the engine and the aircraft, and the work with engine manufacturer will become more and more intense and collaborative if we want to succeed. That's a very important level. Overall, we have concluded that we need to accelerate on R&D. To accelerate because, yes, decarbonization is introducing some new constraints, not game changer, but the panel of technology we have to look at is increasing a lot. Typically, an example of that, this is our potential aircraft for hydrogen-powered aircraft in the 2035. We are looking at very different configuration, from a regional turboprop aircraft to a classical single-aisle or to a blended wing body. We have to make all that quiet. So we have more work on our table to be able to tackle all this configuration and all the technology which has hosted in there. The consequence is that the research roadmap is huge. It's very crowded. So don't misunderstand, and this is not Airbus technology roadmap, which is confidential, of course. This was a deliverable for Horizon 2020 ANIMA project, where Airbus was participating, to list what are all the fields of investment we need for noise if we want to succeed in the noise challenge that we have. So I won't go into details, but you see that we are tackling many, many different things, and the road to sustainability is quite crowded at the moment. To finish, I would focus on three main demonstrators, rigs, that is showing with real things the level of investment we are putting in Airbus to reduce the noise. This is Sapphire rig. So it's a massive engine rig that we will put in the biggest wind tunnel in Europe, in LLF in the Netherlands, and in Modane S1 in France. We are building this rig with Safran. It will represent, at a reduced scale, but still quite a big machine, what will be a new HBR, ultra-high bypass ratio engine. And we will use that to understand all the acoustic aspects, how the short inlet is influencing the noise, what are the type of noise technology you can put as liners, how you should build the fan module to make it more silent. So understanding all the risk of UHBR, we have here a very important milestone in our research plan. Second example, on hydrogen-powered engine. You may have seen that we have launched some demonstrators in flight. So again, we are not planning to make full of hydrogen and A380. It's only a demonstrator on which we will testing the small blue engine you can see there. Why are we looking at this for noise? Not because we want to predict the noise of the engine itself. It's a classical engine. There's no big benefits. But the way we are using hydrogen and feeding the engine, all the new system we'll have, the pumps, the liquid hydrogen ducts and so on, all that are risks for noise because we can have a very small detail which is creating a lot of burden for noise. So we are looking at that, not for the engine noise itself, but for the hydrogen capability of Airbus and to make them silent. The last photo here on the bottom of the slide is another way to use hydrogen. We can use it through fuel cells. So here is more interesting for noise because you will remove all the turbo machinery, no more compressor, combustion chamber, turbine, nothing. We will use instead a fuel cells to convert hydrogen to electricity and then electric motors. So we have some opportunities here because we are reducing some of the noise sources that we have on the aircraft. But still, the propeller will remain anyway, as I said before. And ultimately, we have plenty of new systems like power electronics. We need to cool down all the fuel cells, passively or actively with small fans. So we have plenty of topics here of research for noise, which are very important. I will finish for the last announcement in terms of demonstrators. So in 2025, we will evaluate what is the performance of the new RISE product from CFM, which is the latest of the open fan technology. So as you may see on this visual, evaluation of internal and external noise is the #2 objective of the demonstrator. Yes, we know it's not the most favorable type of engine for noise, but we don't know yet how much. CFM is announcing some tricks to reduce noise that sound interesting. We will see in real life on a real aircraft at scale 1 what it works and see what are the levels we have to reduce noise. This is the end of my talk. Thank you for hearing. Do we have time for a few questions or shall we move to the next speaker? Time for questions.
Thank you very much for your presentation. We really have a few questions that are directly directed to you, and I would like to ask them immediately. You made us curious that there are possibilities, and you won't say anything on that, how to make the open fan more silent. We have one question on the airport Amsterdam. You want to say anything on that? You presented the balanced approach, and there was one question in how far the process triggered by the government at the Amsterdam airport would be according to the balanced approach of ICAO and the European Union Directive 598. Well, everyone who raises questions, please do it in German, then I have to translate it, and I read it out in German. If you only speak English, you can write it in English, but all German-speaking participants, please, in German, because I speak German here.
I'm on the technical side in Airbus. I'm more in the expert career. So here we are really about a political affairs story. I'm not the right person to answer to the question. What I can say that, yes, the balanced approach is an important approach to noise reduction that we really want that we are really supporting in Airbus, that when we need to resort to regulation and limitation in the way we are dealing with aircraft noise, the balanced approach has to be used. The impact analysis, which is taking into account the potential benefits of the various solutions which are proposed, but also the socio-economical impact, has to be done. All the aspects of a new noise regulation has to be taken into account before decision is made. So and I'm not the one that will decide if yes or not Amsterdam Schiphol did the job or not, but yes, for us it's very clear that all the aspects of a regulation has to be taken into account before a decision is taken.
Vielen Dank. Wir haben morgen ja auch.
Thank you so much. And tomorrow we will have another ICAO presentation, and we can ask us the badge. We have a more specific question. Do you see a difference of noise when it comes to the age of a plane? And is the noise getting louder or more serious if the plane is older compared to a younger one?
Clearly, no, we have no big evidence that the noise is getting worse when the aircraft is getting old. We did some studies on the liners inside the inlet, which, as said in the presentation this morning, is a very efficient technology to reduce noise. We have been testing over time, and also, with climate chambers and all that, putting humidity cycles to see if the acoustic treatment is changing. No, it's not changing. We also have installed in Airbus some noise monitoring station on our own around Toulouse Airport, so that we can record the noise of the aircraft and check from our own aircraft, development aircraft from Airbus, how noise is evolving, and we don't see any decay in the noise performance over time at the moment. Unless there's something broken on the aircraft also, but there is a full process to solve this kind of issue.
Okay, vielen Dank.
Thank you so much. And then you showed us a slide on local initiatives. And one guest has a question whether you, as an expert of noise from Airbus, are also committed in local noise abatement activities. So are you also acting locally?
And not even me, but the people from the team, the real people working on noise procedure in their daily life. The engineers of Airbus are going toward the public, toward the citizen association, to explain what is noise, what are their job. Our psychoacoustic specialist is coming to the communities and explaining how she's dealing with annoyance. And so it's not only me as an expert, but the full team of acousticians, of engineers, which are going toward the public and taking part into some local initiatives and improvement if possible.
Okay, vielen Dank.
Okay, great. Thank you very much. And a last question. Based on your tests, can you please explain how low noise and low annoyance models can be distinguished? What's the difference between low noise and low annoyance? Maybe you know what is meant. It's very difficult for me to understand.
I understand, but there is no easy answer. That's why we have a science for that, and that we need to do so much testing. We have some clear evidence that a whistling tone is much more annoying than a very smooth broadband noise. That's very clear, but it's already part of the EP and dB definition, and there is a tone correction to take into account this aspect. So this is typically what we are doing, looking is EP and dB the right metric? Does it represent very well the emergence of a whistling tone and the penalty that you have on the perception to have this kind of tone? For the moment, yes, we have confirmed that EP and dB is the right metric for that, but we are looking for other things, like typically the tonal variation over time, the fact that the noise will vary over time. Does it have an impact? Yes, indeed. If you have a strong and sudden variation of the noise, it increases the annoyance because people will notice that there is a variation in their noise environment, and they will suddenly be more annoyed by the noise. It's typically what's happened with helicopters. Helicopters, it's really a single event perturbation that you have, and that's typically something we want to avoid on Airbus aircraft. Avoid that we have a peak of noise that would disturb more people than a very steady and regular noise content. So this is the kind of thing we are looking at. There is not one single rule. There are plenty of small rules. And we are testing a lot of that through jury testing to test the people on a very regular manner.
Gut. Ja, vielen Dank.
Thank you so much, Mr. Moal. I'm looking at my watch. It's 2:30. We still have a few questions for you, but I will save them for later for our Q&A session, and we will see you. We have you from Airbus, we have Rolls-Royce, we have Lufthansa with us, so I'm going to ask all of you, all the experts. So let me thank you so warmly for your excellent presentation. And now let's carry on with the competition.
Vielen Dank.
Thank you.